In this video, we will understand about what is SDN, that is software defined networking. How is it different from traditional routing? What are its nitty-gritties, benefits, and finally, what are the key vendors which are providing software defined networking solutions in the market? So, here we start. Before going into depth of SDN, let's understand its underlying infrastructure and its underlying working. So, every router switch or any other layer 3 device has got control plane and data plane. Now, what is control plane? So control plane is the one which determines the path for the data traffic. That is whether the next hop should be router 1, router 2, router 3 or router 4. That is what is controlled orchestrated by the control plane. Next is the routing protocols. Let us say we have OSPF routing protocol, EIGRP, BGP, all of them come under the remit of control plane. Next is the network topology management. For example, there is a link failure or new devices added. All these things is the responsibility of the control plane. Next is the security policy. So security policy is about implementing the traffic isolation, micro segmentation, and related things. Lastly, network monitoring. For this, collecting of the data, flows, or device status, everything is under the network monitoring purview, that is control plane. Next, we'll move on to the data plane part of it. So data plane is about forwarding of the packets based upon what CP informs the data plane. CP means the control plane. Whatever information control plane tells the data plane that you need to go towards the next hop, which is the router 1 and non router 2. So data plane will accordingly decide and move towards the actual packet towards the router 1, which is the next hop. Next is the filtering of the traffic. So packet filtering includes blocking or allowing the traffic based upon the security policies which have been implemented. Next, the rate limiting. Rate limiting is about, for example, enforcing bandwidth limit, QoS and related things. Everything is part of the rate limiting function of the data plane. Encapsulation and decapsulation. So let us say the correct headers have to be put in and preparing the payload for the upper layer protocols. All these functions are under the remit of encapsulation, decapsulation, and hence data plane. And lastly, we have the NAT, which is about translating the private IP to the public IP or vice versa, and hence data plane functionality. Now that we've understood what is control plane and what is data plane, now these two entities are imbibed in each of the devices that we can see here. So device 1, which is the router, has both the control plane where the configuration is done and data plane, which is responsible for the actual forwarding of the traffic or NAT or related functions. Same way, this switch also has their own control plane and data plane responsible for taking the decisions and then forwarding the traffic. And finally, same is the case for this switch also. Now, we don't have any SDN here, and each of the entity is using its own control plane for that. And the most important thing is, let us say we need to create one flow. Let us say from here, source A to destination B. For this, the configuration has to be done on this router, this switch, and then this switch. Not only that, but forward and the reverse path also has to be clarified. So in that case only the traffic will end-to-end traverse between these two entities. And this is a cumbersome job because a lot of configuration fine-tuning has to be done for that configuration to be implemented and actual routing to take place. How the scenario changes with SDN. So earlier the scenario was that each of these devices had their own control plane also along with the data plane. But now control plane has been abstracted, removed from here and moved at the orchestrator, which is the central controller for all these devices. It is not only one device, but each and every device from which the control plane, the decision taker, has been moved to the central orchestrator. And whenever any decision has to be taken, it is via that orchestrator, which has the control plane, through the southbound APIs. The orchestrators pushes that configuration or information towards the data plane, that is entities, for them to perform that. And the best part is that it is not that each and every device is configured. Based upon the business need, the policy is enforced, and from the single orchestrator, it is pushed on to each and every entity for end-to-end flow and end-to-end communication. So earlier, the administrator used to log into the each device for that communication between entity A and B, but now via push of the button, all this enforcement, routing, security, everything is implemented, and this to and fro communication is implemented, which becomes quite easier for implementation, faster, flexible, and less of time is consumed. Not only that, cost saving also becomes significant. So in the nutshell, data plane abstraction from the control plane is what we call SDN, or the software defined networking, where data plane stays with the devices, the assets, but control plane is abstracted and taken to the orchestrator, which is responsible for taking all those decisions and pushing that information, as I discussed, through southbound APIs to the end devices. Hence, SDN technology. Key benefits we can incur from SDN technology. First one is the flexibility and agility. By that we mean is that faster deployments can take place, wherein we are changing the configuration as per the demand of the business, and hence it provides us agility also. The second one is centralized management, as we earlier saw that through a single orchestrator we can push all the policy, everything via the control plane of that orchestrator towards the end devices, towards those assets to perform their data plane functionality. Next is the automation and the efficiency part of it. So routine tasks, let us say provisioning, configuration, and policy enforcement, everything is drastically improved via the help of automation, and also provide efficiency because significant time and man hours are saved here. Next is the scalability part of it. In case of scalability, we have separate control plane and data plane, which allows us to further extend and have that scalable infrastructure with separate control plane and the data plane. Now about the cost saving part of it. Since it's not only the man hours which are saved as part of the day-to-day operations, but also earlier we used to have the hardware which were vendor specific, but now we can move on to the commodity based hardware, and through the orchestrator that command can be given because it is only doing the data plane functionality, while control plane has been moved on to the orchestrator part. Next one is the multi-tenancy and the virtualization. Because of virtualization, it has given more opportunity for administrators, for the SDN vendors, in order to have that multi-tenancy also implemented in the SDN portfolio. Finally, faster time to market because of the above given statements, above given benefits. Hence, the time to market drastically reduces thanks to SDN. Key SDN vendors. So there are buffet of vendors in the market who are running SDN technology in their own format. However, that abstraction, that is data plane and control plane extraction, remains the same in all the cases. Now, talking about Cisco. Cisco has its SDN solution by the name of Cisco ACI. Same for VMware, which calls it VMware NSX. Juniper has also got its own portfolio by the name of Juniper Control. Arista calls it Cloud Vision, HPE Flex Connect. Then Nokia calls it Nuage Networks VSP, and finally Huawei, it's Agile Controllers. All have their own USPs, unique things about it. However, the fundamental and the bedrock of how SDN should work remains the same in all of them. Hope you like this video, and please don't forget to share, like, and subscribe. Thank you.